Hi, third graders. Today, I want to talk to you about the idea of equivalent fractions, which we've been talking about in class. Did you notice that the word equivalent kind of sounds like the word equal? And they should, because they kind of mean the same thing. So when we're talking about equivalent fractions, and I want to look at this model, what that means is when I take this whole and I shade one of two equal pieces, or half, I call that half. But if I take the very same whole, and this time we share it into four equal pieces and we shade two of them, we then call that fraction amount 2/4. But it still covers the same amount of area as a half, and we could say, yep, there's still half of it covered. Then if we look at this one, it's actually shared into 6 equal parts, and 3 of them are shaded in. And so we would call that 3/6, but it still covers, the gray parts still cover half of that tall rectangle. So that's the idea of equivalent fractions. They have different names, but they really are talking about the same amount. So let's take a look at some of our calendar pieces. So we had this shape on December 2nd. Our whole all month long has been a square. This square is shared into two equal pieces, and so each of them could be called a half, or one of two equal pieces. Then on day 5, we have the same size square, but it's shared into 3 equal pieces. So in that case, each of them is one of 3 equal pieces, which means they would be called a 1/3 or a third. Then we get to this piece on day 9, and it's the same whole, same square. And now there are 1, 2, 3, 4 equal pieces. So what would we label each of these pieces as? Okay, well, since there's 4, that top number is going to be a 1, because I'm naming this one and it's one of 4 equal pieces. So each of those would be called a 1/4, or a quarter is another name for that. Now I want to go back. So now we have these 3 squares, and we could also write this as 1/2, and 1/2 is equal to 2/2. So we could say that that one square is equal to, or the same thing as, 2/2. If we take this square, we could say that 1/3 and 1/3 and another 1/3 is going to be equal to 3/3. Okay, it took 3 of those thirds to make a whole. Then when we look at this one, I wonder how we could write an addition equation to match this. How many fourths would be equal to 1 square? Well, we again have 1/4 and 1/4 and another 1/4 and another 1/4, and that is going to equal to 4/4. Now the interesting thing is we can actually also write those as multiplication equations. We could say 4 groups of 1/4 is equal to 4/4, because there are 4 of them. Here we could say 3 groups of 1/3 is equal to 3/3, or 3/1/3. And on this one, we could say, how could we write this as multiplication? Give it a try. Oh, how many groups or pieces do we have? 2. And we're referring to halves, and that would be 2/2. Now, the other thing I want to point out to you is because all of these represent the same amount, we have thirds and we have halves and we have fourths, that squares equivalent. They're all a whole. So I could actually write this equation. I could say that 2 halves is equal to or equivalent to 3 thirds, and it's also equivalent to 4 fourths, because 2 halves made a square, 3 thirds made the square, 4 fourths made the square. We could also say that all of those are equal to 1 whole. And that's a pretty important idea in fractions. Now I want to talk to you about one more thing about fractions. And let's take a look this time at halves, fourths. So we have a half, and we have a fourth, 1 of 4. And let's also think about an eighth. Okay, so that is one of 1, 2, 3, 4, 5, 6, 7, 8 equal pieces. So it's an eighth. So if I think about those, I can take my half, and if I make a copy and cut this out, I can take these 2 fourths and I can cover up that 1/2. So again, this is a 1/4 and this is a 1/4. And it covers that space exactly. And because that is true, we could say then that 1/2 is equivalent to, notice we use the equal sign, 2 fourths, because they cover that same amount. Now let's take these pieces, and again, look at that. It also, these pieces cover up that half, and they are eighths. Remember, they are parts of the whole broken into 8 pieces. So I want you to think about, what would the numerator be? How many of these pieces do we have? And what would the denominator be? What kind of piece are we referring to? So what would that fraction be? Well, if we're thinking about how many, there are 4, and we already decided that they are eighths, which means that we can say that 1/2 is equivalent to 2 fourths, and it's also equivalent to 4/8. So take a look at that. They're all the same size triangle, but we can call them different names. It's one of the interesting things about fractions. So thank you for listening, and keep up the great work.